So in this journal here, we're going to be looking at what we've been working on, which is critical points. So critical points are when you take the derivative and you set it equal to what number? Zero, because you usually want to know when the slope is zero. So if you take a look, there's a few places the slope is zero. There's one place right here at x equals 3. So we can see there's a derivative of 0 because the slope is 0 here. Anywhere else? Maybe I'll zoom in.
So
X equals 5 would definitely be a minimum, which also has be a critical point because the derivative is 0 there. And then there's one more. So there's one more, but its derivative is not 0. Anyone see it? 6. Okay. What's up with 6? What's the derivative there? Why does it not exist? It's not because it's a curve. Okay, something about the point. It's a sharp point. It's a sharp corner. Sometimes we call it a cusp. So anytime you have a sharp corner, then you probably have a derivative that's undefined and it still counts as a critical point. So what we're going to do here is they want to know when is the slope of the function or the derivative of the function positive and when it's negative. So let's take a look at these curves for a moment. We can see as it's going from, and by the way, you usually read going towards the right. So if we read this way, is this graph increasing or decreasing? Increasing. Okay, so this is increasing. Let me bring a better pen here. So this is increasing. And then what happens afterwards? Decrease, and then an increase, and then a decrease. So we can see the shape happening. And so we're going to put that on our table here. So what I'm going to do is write down my x values in interval form. So I'm going to write down, let's see, from negative, this would be like negative infinity to 3. So from negative infinity to x equals 3, this is increasing. So I'm just going to put a plus sign. And then at 3, what is happening at 3? What is the slope? Just 0. And then afterwards, it starts to fall down. So from 3 to what x value does it start to fall down? 5. So from 3 to 5, this is negative. And then at 5, the slope is 0 again. And then from 5 to what number does this start to increase? 6. Okay. And then at 6, what should I write? Because the slope is not 0 here. DNE. So there isn't a slope here. And then last but not least, from 6 and onwards, this is decreasing, but where are we going to? 6 to what? Positive infinity. So this is going to positive infinity. And so this is decreasing here. So what I did was I wrote down the intervals and then wrote down if it's increasing or decreasing or 0 or undefined. And that's all. So we're going to practice a lot with this skill today. Not as like formal as this, but a similar idea. So you guys actually have all the skills to do this journal, but we're just putting it all together. And I'm going to show you some easier ways to take derivatives today. So we're going to talk about something called the first derivative test. I'm going to move this slightly upwards. So the first derivative test is basically you're looking at a critical point. So the critical point is usually when the slope is 0 or undefined. And you start to notice that the slope goes from negative to positive. So let me just show you what that could look like. So if I had something that was going negative, then positive, like this. So like this was, the slope was negative, and then it went positive. So at this C value, let's call this x equals C. So what would the derivative here be?
0.
Okay. So if it's 0, would you call this a minimum or a maximum?
Minimum.
A minimum. And so that's where they're coming from, why they believe that this is a relative minimum. So anytime you notice it goes from like decreasing to increasing, you have a minimum. And so you can kind of understand where they're coming from in the second case, where like if you go from positive then to negative, so positive then negative, then this point right here is also a slope of 0, but we can see this is going to be a maximum. And then you have the weird cases when the derivative doesn't change to like both positive or both negative. So let me show you what that could look like. So you might have a graph that looks kind of like a cubic function. So you can see like it's positive and then it still is positive between the derivative at C. So we can see it didn't go from negative to positive or vice versa. It just kept going positive. So there is not a relative minimum or maximum here. Or if you had the other way, it's like say like this, you can see the derivative is negative. So this point right here is not a max or min either because it's still going from negative to negative. So you can only have a minimum when it goes from negative to positive, and you can only have a maximum when it goes to positive to negative. And so those are the 3 different graphs you're going to encounter today. And so what we're going to first do is find where it's increasing and decreasing. So we're going to practice on our derivative skills a lot today. Okay, I'm going to take attendance real quick and then we'll get started with example 1. Let's see. Okay, Isaac is not here today. Robinson, okay, it looks like he's home. Everyone else is here. Okay. Okay, anyone still need this before I move down? All right, let's take a look at this problem. So we're about to find where it's increasing and decreasing. To do that, you need a wiggle graph is what I call it. So to find or to build a wiggle graph, you need critical points. So if you have this equation here, if you take the derivative, let's see what we would get. So we would get a 3x squared for the first term. What's going to happen when you multiply this 2 with the 3 over 2? The 2's cancel, so it's just negative 3, x to the first power. And then if we're finding critical points, we need to set this equal to what number? 0. And because I just noticed these both have 3 x's, we can pull out a 3x. So we can factor out a 3x. And what would be inside? An x minus 1. Okay, let's double check. 3x times x is 3x squared. 3x times negative 1 is negative 3x. So this does work. So once I've split them up, I can set each factor equal to 0. So I'm going to do that real quick. So x is equal to 0 and positive 1. So I have found my 2 critical points. So what we do with that is we make what I call a wiggle graph. So we just draw a line graph essentially, and we go from negative infinity to positive infinity. This is just the x-axis, by the way. And then we're going to plot 1 and 0. So I just do 0 first because it's going from left to right. So we do try to put things in order. So we know that at 0, this derivative is 0, and at 1, this derivative is 0 is because I forced it to be. Because I forced this side to be. And so what we do is we pick a number between each interval so we can figure out what the number, if it's positive or negative. If we can figure out the derivative is positive or negative, to figure out if it's increasing or decreasing. So what I'm going to do is let you guys choose a number. So pick a number between negative infinity and 0, something easy to plug in. Negative 1. Okay. And then pick a number between 0 and 1. 0 and 1 is not 2. But I'll pick over here 2. Like a half, 0.5. All right. So I've picked numbers in each interval to test it out. So what I'm going to do is I'm going to use the derivative because the derivative tells me my slope. And I can figure out if my slope is positive or negative by plugging it in. So just imagine if you plug in negative 1, -1 minus 1 is going to give you, think again,
Oh, -2.
-2. Sorry, that was kind of harsh for me to say, but I was just like, oh, guys, we missed the sign. So -2 minus 1 is -1 minus 1 is -2. If this -1 goes into the x, that means this is a -3. -3 times -2 makes a +6. So this is a positive slope. So if I plug in a 0.5, if I plug a 0.5 in, subtract a 1, that's a -0.5. So this is a negative number. And if I plug in 0.5 into here, this would be positive. So positive times negative makes a negative. Okay. Now, if I plug in a 2 into here, 2 times 3 is 6. So that's positive. And then 2 minus 1 is a 1, which is positive. So positive times positive gives me a positive slope. Okay, so once I have this, the hard part's over. I know between -infinity to 0, this is increasing. I know between 0 and 1, this is decreasing. And I know from 1 to infinity, this is increasing because I now know the slope between them. So all they want is the intervals. So I can say increasing is between -infinity and 0. Where else is it increasing? 1 and infinity. Okay. And then decreasing, there's only one place here. So 0 to 1. And that's it. So that's part A. If you want to find increasing and decreasing intervals, all you got to do is find critical points, make a wiggle graph, and then just find all the numbers between them to kind of test them out. So we're using the derivative to help us find the slope, which will help us figure out if it's increasing or decreasing. So we'll do one more, and then I'll have you guys try one on your own. Okay, so part B. Any questions about part A before I move down? I think that's everyone. Okay, we're gonna move down. So this problem here is kind of tricky with the x being on the bottom, but we've seen this a lot. If you ever want to bring the x up to make this derivative easier, you can call this x plus 9 and then x to the what power? If you want to bring this x up. X to the -1. So we often try to change things, at least for variables, to be an exponent because power rule is so easy to take the derivative of. And so now I'm ready to take this derivative. So if I take the derivative, I get a 1, a -9x to the -2. And I'm going to set it equal to 0. So the next thing I might want to try to do is change this negative exponent back to a positive because it's really hard to solve for x if this stays as a negative exponent. So to make it back into a positive exponent, I'm going to call this -1/9 over x squared because it's a negative exponent and makes the x go in the bottom now. All right, so it's been a while since I've done math like this before to solve, but before I do anything, does anyone have questions about how I changed the exponents? All right. So I noticed like this part right here. So I noticed this was a negative exponent. So that just means this x will go into the denominator to be positive. So anytime you have like x to the -1, it's 1 over x. It's just the reciprocal. So from here, this is where we need to remember about fractions. So if you have something that's not a fraction, subtracting with something that's a fraction, you can make this into a fraction by doing what? Putting it over what? Okay. But we still can't subtract them because they don't have the same denominators. So we can multiply this guy by what to make the same denominator?
X squared.
X squared, okay. So this looks really messy at first, but I promise you it'll clean up very nicely.
I have a question.
Mm-hmm.
On that, on the first part.
Yep.
9x.
-1.
You got the 2 because you combine the x's.
I
Or-
got, oh, so are we okay how I brought the x up, that this is a -1?
Yeah,
Okay, so all I did was I took the derivative and this was a 1. But when I take power rule, 9 times -1 is -9.
mm,
And then I subtracted 1.
okay,
And that's how I got the -2.
okay.
Any other questions? All right, so x times 1 is x squared. And this -9 finally can join it. And so x squared is going to be my denominator. So anytime you get a fraction, we have to treat it a little bit differently. But any questions about how I found common denominators, how I got to here? All right, so when you have a fraction, it's a little bit tricky. If you want the whole thing to be 0, you have to set the top equal to 0. If you want the bottom to be, if you set the bottom equal to 0, what does this help you find? Like what happens when the bottom is 0? It's undefined. So what we do is we take the top and set it equal to 0, because if the top is 0, the whole thing's 0. But we also set the bottom equal to 0 to help figure out when it's undefined. Because critical points, just as a quick reminder, critical points, you usually want to find them when they're 0 or undefined. So D and E. So if I were to solve the first one, it's pretty easy. I just add the 9 over and take the square root. So if I take the square root of 9, I get positive and -3. Okay, so 2 answers. This one, I also have to take a square root. So this ends up being x equals 0. The only thing I do want to notice with you guys, as I'm solving, you should always double check what the original problem. So if you plug in 3, you don't have any issues. What happens when you plug in 0 in the original problem? This part is undefined. So when anytime the bottom's undefined, what do you think is happening at x equals 0? Is it like a corner, an asymptote, a hole? What do you think? It's an asymptote. So like back, I want to say when we were first learning limits, anytime the bottom is 0, you probably have a vertical asymptote here. Not that you need to know that yet until we get to the other problems that are more complicated. But I just want to mention here, this one, if you plug it back in, it causes the bottom to be 0. So this one's probably a vertical asymptote. But it shouldn't affect this problem that we're doing. So we're going from -infinity to positive infinity. We're going to put down our critical points. So we have -3, 0, and +3. And so we know at these places, the derivative is 0. At 0, the derivative is not 0. What is the derivative at this 0? So when you plugged in 0, what?
Well, undefined.
This becomes undefined. All right, so we're getting ready to pick some numbers here. Pick a number between -infinity and -3.
-2.
-2 is not between.
-4.
Okay, -4. Here we go. So if we pick -4, let's plug it into our derivative for a moment. So here's our derivative. If I plug -4 and square it, it becomes +16. Subtract 9, it's still a positive number. If I put -4 and square in the bottom, this becomes a positive number. So if you divide, do you get a positive or a negative? Positive, because it's like a positive number divided by a positive number. So that one worked just fine. Pick a number between -3 and 0. -2, okay. So -2 squared is 4. -9 becomes what number? 5, but is it positive or negative? Negative. So you have a -5 at top. And then if you plug a -2 in the bottom, this becomes a +4. So if you divide, you get a negative number. So I'm keeping track very diligently. You're more than welcome to, write it all on a scrap sheet of paper if you need to see the numbers. So now I'm going to plug in a +2 since you guys picked a -2. So if I plug in a +2, 2 squared minus 9 over 4 is still negative. Okay, do you guys want to just plug in 4? That'd be easier.
Yes.
So if I plug 4 in, subtract 9, divide by 4 squared, is that gonna be positive or negative? Let's see. 16 minus 9, it's gonna be positive. 6 divided by 16, 2 positive, so that's gonna be positive. So all I'm doing is plugging 4 in to both of these x's and seeing if it's a positive or negative number. Any questions about how I got these signs? All right, so let's take a look at our intervals. So we have increasing between negative infinity and negative 3. And then negative 3 to 0, it's decreasing. And then this is also decreasing.
So let's say you have a negative
Mhm.
and a positive same number. Should you get like a positive on both those?
Say that
Since
one
you
more
have a
time.
-4 and a +4, are you always going to get
Oh,
both of them to be the same?
That's a good question. No, not necessarily. It's because of our equation. So if you look at our equation, notice the x are squared. So if they're squared, that's why they end up being the same answer. That's a good observation. Not necessarily, it just depends on the equation. This one's increasing. So we can see there are 2 places it's increasing. Looks like from negative infinity to negative 3, and then also 3 to infinity. And then it's decreasing from negative 3 to 0, so right here. And then 0 to 3. So my first hour asked this question, and then someone else in the classroom actually answered her. So I just want to see how you guys answer this question. So why is it that I have to split up these 2 intervals, even though they're both decreasing?
Because there's a 0.
Right. So I really wish I could say it's from negative 3 to positive 3, but I can't because there's an issue between them at 0. So I have to break them up to make it still continuous. So that's the dilemma with part B. That's it. So once you make this chart, it's really easy to find increasing, decreasing. All right, so for part C, I'm gonna help you get started, but I want you guys to see if you can solve this next one. Anyone still need B before I move up? Oh, we're going pretty fast today. Okay, so this one here, I'll give you a little clue. When you first look at this problem, what type of rule would you use to find the derivative? Okay, interesting. What do you mean by chain? Okay, so you're thinking product rule or chain rule? Okay.
The 12 doesn't have a variable.
It doesn't.
That's why I was like,
So in mathematics, we don't always have to take the derivative right away. We can use algebra to help us make things easier. Like, couldn't I just distribute this 12?
Yeah.
And then this would just be 12 plus 12 cosine x. And I don't know about you, but I think this is a lot easier to take the derivative of than using chain rule or product rule. So if I take the derivative of this, see what you get, but I'm gonna pause here and see if you guys can figure out the increasing and decreasing. So you might need to take the derivative of 12 cosine x, and then set it equal to 0. You might need a unit circle. So this one, if you have a unit circle, you might want to grab it out. So I'll give you guys a couple minutes to see if you can figure this one out. Yeah.
I think I'm gonna show it to you. Do you want me to show it to you now or just put it on?
Which one is it?
7.
7? Okay. You can sit down. I'll bring it to you. Mhm. Yeah, grab pass. All right, so I'm going to try to catch up to you guys. So did you guys get negative? So the 12 goes away, but then the 12 cosine becomes negative 12 sine x. Okay, then set it equal to 0. You have to move over the negative 12. So this just ends up being 0 sine x. I hear a lot of yeses. All right, I divided it over.
Oh, okay.
So I divided over the negative 12, just have a sine x from here. And x is equal to, let's figure this out. So we basically want to know when is sine equal to 0. So if you look at a unit circle, let me draw a unit circle here. So if you look at a unit circle, it goes from 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Now it only wants us to figure things out from 0 to 2 pi, so 1 revolution. If you look at a unit circle, this coordinate right here is 0, I think 1, 0, and then this is 0, 1, negative 1, 0, and then 0, negative 1. If you're looking for sine, are you looking for the x or y coordinate? Okay, so if this is a y coordinate, the y's that are 0 are right here and right here. So that means 0 works. That means 2 pi works and pi works. So x is equal to 0, pi, and 2 pi. Just to test you guys out, if this was cosine x and this was 0, when is cosine equal to 0? What angles is cosine equal to 0? Pi over 2? Where else? 3 pi over 2? Yeah. Did I mess up somewhere?
No, I was just thinking, why would you divide it over, but it's connected to the sign.
Yes.
So that makes sense.
Yeah, I noticed it's like sitting next to it, so I have to divide it over.
Okay.
Whenever it's like this, then you add it over.
Yeah.
Any other questions? I'm trying to see if I messed up anywhere, but I don't think I see a mistake yet. So we have our x values, but we need the increasing and decreasing intervals. So I'm going to draw a line graph. Now, because it only goes from 0 to 2 pi, I don't want to put infinity signs. I want to chop it off at 0 and 2 pi. And so the pi is going to go on my my interval. So I have 0, pi, and 2 pi. Here's the derivative at 0. And I just need to figure out the derivative in between. So let's pick out some numbers. What number on the unit circle would be between 0 and pi? Maybe something easy.
2.
Like pi over 2?
Yeah. Yeah.
Did you pick 2 like on the from 0 to 3.4? 2 is fine, but like on the unit circle, it just might be easier because I'm noticing from 0 to pi over 2 is between them. What is between pi and 2 pi? 3 pi over 2. You're more than welcome to pick whatever number, but it's just to make things a little easier. So if I picked pi over 2 and I plug it into my derivative, which is sine, if I plug it into this derivative, I get, oh wait, which one's my derivative? This is my derivative, my bad. If I plug in pi over 2, this would make this sine a 1. So if this is a 1 times a negative 12, what would this angle be? Negative 12. So this is a negative. And then if I plug in 3 pi over 2 into here, this sign would be negative 1. If I multiply by negative 12, I get positive. Okay. So I know that this side is increasing. Oh, sorry, decreasing. My bad. I knew I was going to mess up somewhere. And then this one's increasing. So I'm going to write in my interval. So this is increasing between pi and 2 pi and decreasing between 0 and pi. That's it. So this one was a little bit long, so let me just do an overview. You had to take the derivative and you get negative 12 sine when you take the derivative. You set it equal to 0, you find sine is equal to 0. You had to use the unit circle to find these angles, and then you just make a wiggle chart. All right. I think what I'll do is I'll start the next one, but I'm not going to finish it. I'm going to just work halfway through it because I want you guys to try it on your own too. So just out of curiosity, if you look at this wiggle table for a moment, this goes from decreasing to increasing. If you know that much, if this goes from decreasing to increasing, what is this? What's happening at pi? It's a minimum. You have a minimum. So that's what we're going to try to do next is we're going to locate relative mins and max. All right. So I think if you're ready for the next one, you can kind of go down. Let's see, which one is this one next? Oh yeah, this one's a hard one. This one's a good one. Okay, anyone still need the board before I move down? Okay, so this one, my first year I got into a few dilemmas here with this one. So it says use the first derivative test. So we're going to take the first derivative, but it wants us to identify extremas. And so that means find relative max and mins. Anytime it says extremas, like the extreme value, so the max and mins. So we need to take a first derivative. Here's the thing. When you first look at this problem, what type of rule would you use to take the derivative? Okay. If I didn't want to use quotient rule, how do I avoid it? Say that again. Well, if I multiply the bottom, I have to multiply this side, and it gets.
You do a negative exponent.
I can do negative. Okay, so you mean like bring this up in a way? Okay, that's a good idea. My first year didn't come up with that. Okay, yeah, I could do that. What else?
You do quotient rule anyway.
just go through the pain. All right, I'm going to show you one more skill today. I think this will ease some of your guys' pain. When it comes to division and you have a fraction, you can actually split up the top. Like you can actually do x to the 4th over x squared, as long as you take every term on the top. So this one also needs to be divided by x squared. When you do it this way, what do you guys notice about this term? Okay, what is it reduced to? X squared, because you guys have learned that division with exponents you subtract, so it's x squared, because 4 minus 2 is 2. And then this one here, you could try to change it to an exponential if you bring this up. So what is the second, what do we call this one? X to the negative second power. And so with a little bit of algebra, you can turn this problem into this problem. So I don't have to use quotient rule. So if I take the derivative, this would be 2x to the first power minus 2x to the, what would my new power be if I subtract 1? Negative 3. And that's it. So by the way, you could have taken quotient rule. It's perfectly fine. But I want to show you how easy it is to not use quotient rule either. All right, any questions about how I manipulate it right here? So anytime you have two things on the top or multiple things, and you just have one term on the bottom, you can divide each one of them individually. All right, so going back to this becomes 0 on this side because this is a critical point. I'm going to call this -2 over x cubed. So because this is x to the -3, I'm going to bring it to the bottom to make it a fraction. And then I run into the same dilemma as earlier. This one's a fraction and this one's not. So I'm going to force it to be a fraction by putting it over 1. So what would I need to do to make common denominators? Okay, you're thinking x to the 3rd power for top and bottom? All right, so this becomes 2x times x cubed, which is 2x to the 4th power. And then 2 just drops down, this 2 just drops down. And then the denominator is x cubed. All right, we finally get to our fraction. We can work with fractions. So with fractions, you need to set the top and bottom equal to 0 to find critical points. So I'm going to take the top and set it equal to 0 and x cubed equal to 0. Clean this up a little bit. So this one's pretty easy. If I take the cube root on both sides, x is just going to be equal to 0. For this one, on the other hand, I need to get x4 to the by itself. So I'm going to move over the 2 by adding, and then I'll divide by 2. When I do that, if I add over 2, divide by 2, what number would this become? Oh, did I go too fast? I can slow down. So I'll show all my work. So if I add over 2, and this becomes a 2 here, divide over 2, you guys said 1? Okay, so if this is a 1, I need to take a 4th root to get rid of a 4. What is the 4th root of 1? I heard 1. Okay, is it just positive 1?
No, it's just 1 because it's positive.
Okay, you ask yourself. So if I plug in a 1 and took to the 4th power, it is 1. If I plug in a -1, is it still positive 1?
No.
Yes.
I think you need to work it out. So the -1 to the 4th power is -1 times -1 times -1.
Yeah, it'd be plus or minus.
It's definitely, so it's plus and minus. So what did you guys notice about even roots? Whenever you have an even root, it's always a plus and minus. Odds don't care about the signs as much. It's never a plus and minus, whatever's inside. So even roots are always plus and minus. That's a good observation to make. Okay, let's make a wiggle graph here. So we're going from -infinity to infinity. Now I'm going to check my values here as I'm going. So if I have -1 or +1, if I plug it in, I don't see any issues, major issues in the original function. What happens if I plug in 0 into the original function? It's undefined. So what can we say about this x value, like when we graph it? Okay, it doesn't exist. What else about it? Is it like a corner, an asymptote? It's probably a vertical asymptote. So I'm suspicious whether this is a vertical asymptote. That's a weird arrow I drew. So I'm going to plot my points first. This is -1, 0, and +1. And so we have the derivative is 0 here. The derivative is undefined here, d and e. So I'm going to pause here for today. For you guys, I'd like you to figure out what is the signs in between here. And then next time we'll pick up on this problem. So I just want you guys to figure out, pick a number between each interval and figure out what's the sign in between it. And then next time we'll pick up. So I'll leave that up on the board. If you guys have journal, I want to say it's 21 or below. I'll grade it today in class.
Is this still?